late, so I will have to rush through a lot of the slides, and I'm sorry they don't show properly, but everything is going to be online. So I'll cover a little bit with what happened with the Google Summer of Code. So essentially, OWASP received 18 slots from Google, so this meant we could take 11 students, and the problem is we got 84 proposals, so 87% of the students couldn't be selected. And the final slot breakdown was that OWTF and ZAP got 4 slots, and then you can see all the projects there, the academic and mod security and PHP security project got 1. In the Google Summer of Code, the overview for OWTF students is that 14 showed interest. From those, only 79% or 11 bothered to submit a proposal. 16% of OWASP proposals were for OWTF. We got 5 in the top 11, but we lost 1 student because he was accepted both by OWASP and another organization. And in the end, we got 4 students. So some people were kind of surprised because OWTF is not as well known as, for example, mod security, which is a project everybody knows about. So we are wondering, well, why did so many students submit? And some said it's because it's Python, others said because they liked the project that was being proposed, or they saw it's a project they can do with their skills, or someone said that it's the best project to learn about other tools of security because OWTF tries to cover all the OWASP testing guide and the penetration testing execution standard, so we ran a lot of tools, and that means like the focus is really broad and you get to play with other tools. And another funny one was that another organization didn't reply, so the student decided to send the proposal for OWASP because we were quicker to reply, or quick feedback, encouragement, or advice. Okay, so these are the 4 projects that I'm going to cover briefly. And a big thank you for all the dedicated mentors that stepped up to mentor with OWTF, because I can only mentor like up to 1 student. So each mentor can only mentor up to 1 student. So we needed like 1 dedicated mentor per project, and all these people stepped forward to help. So big thank you for them. So let's have a quick look at what OWTF is. Essentially, the goal of the project is to try to use the pentesters' time as efficiently as possible, because what happens is we have very limited time to test. So the way we try to do this is separate and test so that you can start without permission. And we'll explain this a little bit later, through automation by launching a bunch of tools and making human analysis as fast as possible. So the approach is running tools, running tests directly. So when we don't really find a tool that does something specific from the OWASP testing guide, then we try to write our own tests. And then it acts as a knowledge repository. So it's not just about automation, it's about trying to help the human exploit the problems so that we can show impact to management, right? If we just give management a black screen or a text file, they typically don't get the problem very well, but if we can show impact, then the issue is going to be more likely to be fixed. And then we have an interactive report. So this is a little bit cut as about helping the human analysis, but I'll explain this in a few seconds. So there's 3 main plugins. There's web, there's net, and they're auxiliary. So the web plugins try to cover the OWASP testing guide. The net plugins are a little bit like mmap scripts, so they try to probe for network services. And auxiliary plugins are a little bit like the MSF CLI way of calling Metasploit. So it's just shell one-liners to do some stuff. For example, this is an example to run a targeted phishing attack through the social engineering toolkit. So things like this. And this is, I said before that OWTF tries to help the human, the pen tester, to test security as fast as possible. And one of the ways to do this is to start testing before we have permission. And this is possible because we divide the tests into passive, semi-passive, active, and then there's external and grep. So passive will essentially not send any traffic against the target. So we are basically testing through third-party sites. Semi-passive, we send traffic, but the traffic is normal looking. It's like a normal user visiting the site. And then grep plugins are essentially doing searches on HTTP transactions, and external plugins are meant to help the human exploit the problem. So the OWTF report, which I'm going to show in a minute, is meant to emulate the thought process of a chess player. So when a chess player plays chess, there's a bunch of moves that are legitimate, but there are many moves that don't make any sense because they're going to lose quickly. And what they do is chess players analyze in two sweeps. So there's a first sweep when they look at all the possible moves, and from those they try to reduce the scope, the breadth of that, to just 3 or 4 moves which are going to be the most promising, the ones that look the most promising at first sight, and then those are the ones that they are going to analyze more deeply. So the reason for this is that most people in chess, in life, and in testing security, when they see something bright and shiny, they just go straight in one path without looking at the whole thing first. So we all had this problem. If you have tested security, you have been here. Like you saw something that looked really promising, at the end it was not exploitable, and you had something that was better and was just beside it, and you didn't even look at. So it's the same problem we have. So this is what we are trying to do from the report, and I'm going to show a quick demo, hopefully. Well, I'm going to show the second one because we're short on time. The second one is a little bit, oh no, well, whoops. No, I'll show the first, sorry. Hopefully. Okay, so essentially we're running OWTF, we're running just the passive plugins, but the pen tester doesn't work here. This is the command line. We just run OWTF from here, but the pen tester works on the interactive report. So we're focusing on the target. We see all the OWASP testing guide tests. We are using the filter, just showing the passive plugins. And then we're just reviewing the information here and ranking it. So this is the first sweep of the chess player, right? So we are discarding a lot of things. These are Google searches that we do with clicking this open all in tabs button. So we are just marking the test as passed because we didn't find anything useful. We did open all in tabs again. We are closing all the tabs, all the Google searches that didn't yield any results. So we are marking all those tests as passed because we found nothing useful in there. And now when we run this test, we find that there's Sitefinity administrative interface. Right, so now this is interesting because if we can get in this way, this can be a big problem, right? So what we're doing is we are taking a screenshot of what we found, and then you can click on edit here and you can start reporting. Now the important thing to note here is that this is all passive testing. We are not touching the target at all, but we are already starting reporting and we are already doing a bunch of tests. So we can paste the screenshot in there, and we can start like writing down what we found, that there's an administrative interface here, that this is the URL for it. Okay, so I'm going to write it now there. So you can see like I'm starting like writing the finding, right? So there's an administrative interface. We still don't know if we can get in that way or not, but we are already writing this down. And now a thing I want you to pay attention to is that now when I click on the eye here, this is going to take me to show the external plugin. So this has a link to the White Hat page for the Badmin project, which is essentially a website that has information about the most popular CMSs. And in here we are grabbing the information for Sitefinity with the default administrative password. There's as well a link for exploits against Sitefinity. And what I'm doing here is I'm noting the things to try, right? So when we have permission, we can try these default credentials for this CMS and see if they work or not. And we can start preparing all the attack. And these are the published exploits against that CMS. So you can see here that we are using the OWASP testing guide as a checklist. We are marking very quickly what is not interesting for us. And I'm really not trying to exploit the problem. So in here, I'm just marking this as interesting, right? So potentially exploitable, but we are not trying yet. And I'm still trying to finish the first strip. So I still have other items to look at, and I'm just marking them as passed because I find nothing interesting in there. So that's the idea of OWTF. Right, to coordinate the human analysis with the automated tools and third-party sites and proof-of-concept exploit code that is publicly available. So now we can use the filter and look what is the most important thing that we found on the first strip, and that's there. And then there's a magic bar that you can click, and that's going to show you all your findings. These are the human findings in the report that you started. And they are in an easier to copy format for the real report. Okay, now I think we are going, well, the thing is, then after trying this, after trying the default credentials, just 1 minute after getting permission, you can get in, if they are vulnerable to that. And then 5 minutes after getting permission, you have a shell. So the pen tester is using the time much more efficiently than usual, right? Like no matter how good of a security rockstar you are, there's no way you get in 5 minutes without all this preparation. This second demo I'm going to skip because we're a little bit short on time. And then, well, we got 5,000 euro from Brucon and 2,000 euro from Google. So I think the best way to use this money would be to help the students that got accepted and keep them working on the project after the Google Summer of Code. But if you have other better ideas, just please let me know. And I'm just going to show very quickly what the status of the Google Summer of Code projects are. So with the reporting project, the main issue was that the old report was a little bit ugly. So it's difficult to understand and all this. So we had a bunch of goals, make it more intuitive, easier to use. And a very important thing here was to move all the HTML into template files so that a designer can help us. And then we chose Twitter Bootstrap. We chose Jinja 2 as a templating engine. And we did a survey to gather community feedback. And this was the chosen prototype, so it looks hopefully a little bit better. This is what people voted as the better looking report. Okay, so this is still being on the works. This prototype is still being implemented, and a very important feature as part of this project is that we are going to have default plugin vulnerability ranking, so that even though we always give the human the possibility to override the importance of the findings, because that's a very important concept for OWTF, we want to give some guesses, automated guesses of potential rankings, so that if, for example, you have 50 websites that you are looking at, you know which is the potentially weakest one as soon as possible through the automated results. Then there's one of the other projects is multiprocessing by Ankush, and here the main goal was to reduce scanning time and to port the OSCP scripts into OWTF. These were the scripts that I used to pass the Offensive Security Certified Professional certification, which is a 24-hour hacking challenge, and I did this back in 2008, where I had very little idea about security, and using the scripts, despite being so weak, I could get a 100% score in this test. So they were pretty useful scripts. We chose multiprocessing for running plugins and threading for other smaller tasks. And yeah, I'm going to skip this part. And then the thing with the network plugins of the porting these scripts is that they work with waves. So if you use OWTF and an IP address, by default the waves are going to be first scan the top 10 ports and try to find vulnerabilities on those, then the next 90 until the top 100 most likely open ports, then the next 900 until the top 1000 most likely open ports. So we only scan each port once, but you are going to have results much more quickly, right? How many times have you heard that while I was waiting 10 hours for the map scan to finish. So what we're doing with this way, and this was one of the key factors why I got the 100% score in that 24-hour hacking challenge, was that I had results in 5 minutes. So I had the 24 hours as time for myself to think on how to exploit everything. I had the information much more quickly than other people taking the test. So this is the idea with OWTF as well, because the ultimate goal is to make security testing as fast as possible. So network plugins implement vulnerability probing of network services like FTP, SMTP, SNMP, and all these other services. And yes, we will try to improve performance a little bit more. And yeah, and I'm going to skip to the proxy project, which was a very impressive project. So essentially, what we want is to have more information to analyze and to proxify tools, because we are running a bunch of tools like Skipfish, W3AF, and a bunch of other tools. So what we want is have the information that all those tools gather, so that we can analyze those with grep plugins to look for all those HTTP transactions. Can we find any vulnerabilities on that, right? And some of the features like the proxy cache to avoid redundant requests. So the research that this student did was very impressive, and in the end we chose Tornado as the framework to write this Python proxy. And I'm going to skip that. And essentially we have SSL man in the middle working, we have the proxy cache working, and there's the race conditions for saving files in the cache is also working. And the bottom line in this project is that the OWTF proxy is now the fastest Python project, the fastest Python proxy ever created so far. So in the benchmarks that the student has done, we are faster than Twisted, we are faster than man in the middle proxy. So he's done a really impressive job, and yeah, and it's quite great. Yes, and one of the things that Simon talked about before was this plug and hack interface. So we're going just finish right now, or okay, yeah. And so this support is standard, and then yeah, and then the other project is the testing framework. So in the end, in here, what we want to do is to focus the project into functional testing. So testing, does the output of OWTF, for example, if we run a plugin, is it really what it should be, right? So that is the focus of the project now. And yeah, so writing functional tests to see if we are really covering the OWASP testing guide, and try to cover the penetration testing execution standard. So we are writing tests for those. And another big one in this project will be automated continuous integration. I cannot make justice to the awesome work all these students did, but that's all the time I have. So if you, I don't know, if you want to have any questions, you can. I have to leave now for my flight, but I can give you a business card or something. Yeah.
Okay, so thank you very much for the speaker. So do you have to